Hey, good morning, algebra. Here's the do now for today. Go ahead and distribute. I will hang out while you distribute. You can hit pause till you got your answer. Yep, I finished waiting. So we distribute that negative 13. We're going to multiply it onto each of the terms inside the parentheses, and we end up, follow that green arrow, end up with negative 26x, and follow the purple arrow, negative 52y. And remember, the negative on the 13 comes with the 13 both times. We're going to take that negative on the 13 when we multiply it by everything. It's easy to forget. We'll do it once, and then the next time you're just like, it's times 13. You get the negative sign there. Hey, so looking at substitution today, still solving systems of equations. Our learning target is unchanged. You'll be able to solve a system of equations using substitution. And today we're going to look at some problems which are a little bit more challenging. So we got these same steps to do substitution, a 4-step process. So we're going to start with a system that has two equations. Choose either of those two equations and solve that one equation for one variable. So choose either of the equations, doesn't matter. Choose either of the variables, either x or y, doesn't matter. Maybe one is easier, maybe not. Step 2, once you've got that first equation with one variable isolated, we're going to substitute that into the other equation. Step 3, solve for the variable which remains in your new combined equation. Step 4, once you get that first variable, whether it's x or y, you find out, oh, here's what y equals or here's what x equals. Take that, put it back into either one of your original two equations and solve for the other variable because we need both coordinates, both the x and the y. So an example, here we go. Solve the system of equations. I get a green equation, x equals 2y plus 5, and the blue one, x equals 3y minus 2. So a little bit of a mind game here. We don't actually have to do anything different on this problem than what we did in the previous lesson. But instead of y equals form, both of these equations are in x equals form. We've never seen that. It doesn't mean anything any different. So I know, let's say from the green equation that x equals or is the same as 2y plus 5. If those are the same as one another, then I could use them to make a substitution. So we'll say the green one, that's the coach's clipboard. I got these two soccer players that both play the same position. One of them is named x, the other one is named 2y plus 5. The blue one, let's say that's the soccer field. And so there's x out in the game playing. We're going to take x out of the game. And in her place, we're going to put the 2y plus 5. And you totally could have done this with our little analogy the other way around. You could have said, oh, the blue one is like the coach's clipboard with the players named X and the other player named 3y minus 2. And the green one is like the soccer pitch, which would have worked for the analogy color perspective. Soccer fields are green. And then we could take the 3y minus 2 from the blue one, put it into the green equation in the spot where X is. You'd end up with the same answers in the end. Obviously, it's going to look different in the meantime, but we're just going to go ahead with what we got here. So I'm going to rewrite this without the scribbles. So 2y plus 5 equals 3y minus 2. So there, I've made the substitution. I took that 2y plus 5 out of the green equation, put it into the place of x in the blue equation. So now I have combined both equations through substitution. I have only one variable in that equation. The one that I just wrote in purple only has a y in it. So now I need to solve for y. I don't like having negative numbers, so let me get this set up. I guess we'll just do all of our dotted lines in red. That's totally fine. It's going to make this one thicker. So that one is the equal sign, so I got to pay special attention to the one where the equal sign is. Okay, so I want to get the y's together on one side of the equal sign. I'm going to choose to subtract this 2y because this will give me a positive y in my next line down. So the first column, that cancels, there's nothing left. Next column, I have positive 5. I can just write 5. It means the same thing. Equal sign comes straight down. Third column, 3y minus 2 gives me just 1y. I don't need to write the number 1. I can just put y, and that still means that there's 1. And then the last column, that negative 2 is going to come straight down. And my next step, I need to get the y by itself. So I am going to do the opposite operation. We'll add 2. I'm going to do that on both sides of the equal sign. These cancel. Next line down, 5 plus 2 is 7, equal sign, and y. So y equals 7. The order here doesn't, if you have 7 equals y, means the same thing as if we'd rearrange the whole thing to get y first, y on the left side, y equals 7. We're going to get the same thing. It just saves us a bunch of work. 7 is the same as y is the same as 7, means the same thing, whether you say it forwards or backwards. So we're good. Y equals 7. So there's half of our solution. Now, I'm going to choose either the green or the blue original equation and put 7 into the place of y. So I was going to use parentheses to hold the place of y. And now let's put 7 into that spot right there instead of the y. And we'll do some mental math here. 2 times 7 is 14, plus 5, 19. So x is 19, which means my solution, I always put the x coordinate first. So parentheses, 19, comma 7. Close my parentheses. Oops. There's our solution. Next example. Okay, so here's where things do get a little bit more challenging. It's not just a mind game. Actually, there's going to be some different work we need to do here. So I have 2 equations, a green one and a blue one. An important thing to notice here is that the blue equation already has x isolated. So that first step in our 4-step process is to choose either of the equations and isolate for one of the variables. Okay, solve either equation for one variable. It doesn't matter whether it's the x or the y, and it doesn't matter which equation. I've colored them green or blue. You can choose either one. So in this case, the blue one has already been solved for x. So I'm going to choose the blue equation to solve for x because it's already done. And then here's my substitution. X is the same thing as negative 2y plus 3. So I'm going to take the negative 2y plus 3, and that's like my substitution coming off the bench, going into the game. Next, it's going to take the place of x in this green equation right there. So let's start by writing the green equation. I'm going to use a set of empty parentheses to take the place of that x that's coming out. So I'm going to write the whole equation here in green. I'm going to strongly recommend that you take this approach and use those empty parentheses, whether you're using different colored pens like I am, or just writing it in pencil, because we need that space where the x was to fit the whole part of the blue expression, negative 2y plus 3. That whole thing has to fit in here. And not just fit in there, but that whole expression is going to need to be multiplied by 5. We're going to have to distribute, just like we saw in the do now. So I need to stop for a second and just recognize what's happened. I've done my substitution. I still have a lot of work to do to get my solution, but I've done the substitution. I took the blue part of that equation and I put it into the green equation in the place of x. Okay, so now let's distribute. So 5 is going to get multiplied into both of the terms inside the parentheses. So 5 times negative 2y, that is negative 10y. Let's change colors. 5 multiplied onto the 3. It's going to be positive 15. All the rest of the green equation needs to come straight down unaltered. So minus 3y and equals 2. Okay. So pay attention to the location of the equal sign. Okay. So at the equal sign, this is where I'm going to keep track of my equation, keep everything balanced. Same thing, whatever I do on one side, I have to do the same thing on the other side. Okay, before I even get there, here's my equal sign. On the left side of the equal sign, I have like terms. I got a negative 10y I got minus 3y. Those are both y terms. I can combine them. I don't need to do any opposite operations because they're together on the same side of the equal sign. So I can just combine them. It's like adding them together. In this case, it's actually subtraction because it says minus. So like terms, we'll highlight them both in yellow. And then, okay, so negative 10y minus 3y is going to give me negative 13y. That plus 15 is still there. This equal sign comes down, that 2 comes down. Sorry, I scrolled too far. Okay, so still need to solve for y. In this case, I did not end up with y on both sides of the equal sign. So I didn't have to like bring them together. They ended up on the same side of the equal sign, and I combined them as like terms. I still need to get the y by itself, and so I'm going to do opposite operations to get the y by itself. So let's subtract that 15. So negative 13y comes down, equals comes down, 2 minus 15 is going to give me negative 13. To get the y isolated, now I'll need to divide by negative 13. I use parentheses to keep that negative sign attached. And on the other side, let's just write it with the division line. So divide by negative 13 on both sides. Negative 13 divided by negative 13 is 1. This is going to give me just one y. I could write it as just a y. And on the other side of the equal sign, negative 13 divided by negative 13. Also, it's just 1. There's not a y this time. It just equals 1. So y equals 1. So I've done most of the work. Not totally out of the woods yet. I still need to get the x coordinate. So I'm going to take that 1. That's the value of y. Let's go back up to the top. So I'm going to choose either of the two original equations and substitute 1 into the place of y. You can do either one. You're going to get the same answer. In this case, using the blue equations can be way easier because it's already solved for x equals form. So if I will not have to do nearly as much work. Take the x equals negative 2, empty parentheses, plus 3, and then 1 is my y value. So this is already set up to just tell me what x equals. I just do a little bit of mental math here. Negative 2 times 1 is negative 2, plus 3 is 1. Well, that makes it seem super simple. We get a solution like 1, 1. Well, that was not a simple process, was it? We had to do quite a bit of work to get here. Not too difficult, but we definitely had to do some work. We want a more rewarding solution, something that's going to be like, yeah, I worked hard. That was a hard answer. It was like 17 and 104, that would make it seem more rewarding. But we don't really want to have to deal with numbers that are that big. So I'm happy with 1, 1 as a solution. Okay. Last example. So I got, again, 2 equations, a blue one and a green one. And again, in this case, one of the equations has already been solved for a variable. So the green one is in y equals form. That's going to make it a lot easier if I choose this as the basis of my substitution. So I know y is the same thing as negative 2x minus 9. So in the blue equation, I'm going to take the y out of the game, make a coach's substitution here. Negative 2x minus 9, get in there. Okay, so let's rewrite this. So I got 3x plus 5, empty parentheses. I will come back and fill that in with the other color, equals 4. And then whether you're changing colors or not, we need to get that whole expression from the green equation, that negative 2x minus 9. That whole thing has to go inside the parentheses. We need to have parentheses there because we are going to have to distribute that 5 from the blue equation. That 5 is going to have to be multiplied onto each of the terms that we brought from the green equation. So let's go ahead and do the distribution now. We are ready. So 5 gets multiplied onto the negative 2x. Oh, you know what? We're not ready to do the distribution. Hold on. 3x plus, that's going to come down first. And now, back to purple, 5 multiplied by negative 2x. That's negative 10x. Okay, before we go any further, if I'm adding a negative number, That is the same as subtracting. Let's just get rid of the plus sign and call it 3x minus 10x. And then let's keep distributing. So I'm going to take this 5 and multiply it onto the second term, which is -9. 5 times -9 is -45. Just write that as subtraction. Equals comes down, and that 4 from the blue equation comes down. We've not done anything to it. Okay. At this point, I keep track of that equal sign again. On the same side of the equal sign, I got like terms. I got a 3x and I got a minus 10x. Those are like terms. I can combine them. No need for opposite operations. I'm not moving something from one side of the equal sign to the other. They're both together on the same side. Just combine them. So in this case, subtracting, it says minus, I will subtract. So 3x minus 10x. Highlight those. They're like terms. And let's subtract. 3x minus 10x is negative 7x. The rest of this equation just comes straight down. So minus 45 equals 4. Now I need to use opposite operations to continue solving for x. So we'll add 45 to both sides. So negative 7x equals 49. Last step, divide both sides by -7. Write that in different forms, just so we continue to see division written in multiple ways. Okay, so -7x divided by -7 is going to give me just 1x. The -7 divided by -7 gives me 1. So x, equal sign comes down. 49 divided by -7 gives me an answer of -7. There's the x coordinate. Halfway there. I've done almost all the work, but only half of the solution so far. So that -7, remember that, it's going to come with us. So let's take it back up here. We're going to substitute that back into either of the original two equations, either the blue one or the green one. Of course, the green one is going to be way easier because it's already solved for y equals. So it's going to make it a lot easier to solve for the y coordinate. So y equals -2, parentheses, -9. So I'm going to put that -7 as the x value right here. And then we'll do a little bit of mental math. -2 times -7, that's positive 14. 14 minus 9 is 5. So the x coordinate goes first, -7. The y coordinate goes second. That was 5. Doesn't matter what order you solve for them in. X coordinate always gets written down first, and the y coordinate always gets written down second in your coordinates. All right.